In this video, we shall look at how to do integrations with substitutions. Let's see how this works. Assume that you have to integrate a function gx with respect to x. Upon inspection, let's assume I can rewrite that function gx in terms of, say, fx and its derivative. Let's call it f prime x dx. What we are doing here, we have identified the original function gx and have rewritten it as product of two functions fx and its derivative with respect to x. That's what we have done. Now we are ready to make substitution. Let's make the following substitution. Let's assume u is fx. So that means the differential of u has got to be df dx dx, which is just f prime x dx. If we substitute u and du in this integral, we will end up with the following expression. fx is u and f prime x dx is just du. Note that this f prime is just df dx. And we know how to do this integral. It is just half u squared. And let's not forget the integration constant c, because the original integral has no limits, so therefore it is an indefinite integral. Substituting back the expression for u in terms of f, the answer for the integral is just half fx square that plus the integration constant, and that's the final answer. With this technique, the idea, or the challenge rather, is to identify fx and therefore f prime x from the original function gx. Once this is done successfully, the integration can be done relatively easily. Let's look at the following integral. Now this entire thing is like your gx. The task is to determine fx and therefore its derivative with respect to x. What are they? We can get a clue by looking at the argument of that radical sign, x cubed plus x squared. You see that when you take the derivative of x cubed plus x squared, you will get 3x squared plus 2x, which is just the term in the numerator. So that suggests we can take our fx to be x cubed plus x squared, and let's take that to be u. So 3x squared plus 2x dx is just du. Substituting these in the original integral, we get the integral of du over square root of u, which is just 2 square root u. It's just an elementary integral that we have discussed in our previous videos. So the original integral, let's call it I, is therefore 2 square root u, but we know u is given by that, so square root x cubed plus x squared plus an integration constant, a c, which we should have written here as well. And that's the result of integration. What about this integral? Let's call this integral j. Now again, this entire thing is gx. So we have to identify fx. So in this case, we can try fx as x squared plus a squared. A is a constant. Now how do we know how to choose this? By guesswork. We note that if you do this, your f prime, it is just 2x. While this is not exactly the same as x, but we can make it to be 2x by simply multiplying this entire integral by half and multiplying the x term with 2, thus creating the following form. If we take the x squared plus a squared to be u, then 2x dx is just du. So let's write j in terms of u. So 2x dx is just du. X squared plus a squared is u. And don't forget the power, which is n. Again, n is a constant, so this is an easy integral to do. It is just u n plus 1 over n plus 1 plus a constant. Substituting the expression for u in terms of x in here, we get half 1 over n plus 1, and u is now x squared plus a squared. Don't forget the power n plus 1 plus the integration constant. And that's the final answer. What about this integral? Let's call this integral again j. What do we use for fx? Now you note that the expression in the bracket is 1 minus 3x. So that means if you differentiate that with respect to x, you simply get minus 3. And on top you have 1. So that should give us a clue. Let's assume fx is 1 minus 3x. And let's rewrite the above integral in a following manner. If we multiply the integral with minus 1 over 3, then the numerator will become minus 3, just the derivative of 1 minus 3x with respect to x. dx over 1 minus 3x to the power 3. We can see that these two integrals are identical. They're the same integral. We only did a slight modification in the terms, sort of trick, if you may, so that we can use the substitution to solve that integral. Let's take 1 minus 3x to be u. Then minus 3 dx is du. Substituting that in j, you get minus 1 over 3 minus 3 dx is du, so that's just du. Over that is u to the power 3, which will be minus 1 over 3 integration of u to the power minus 3 with respect to u is u minus 2 over minus 2, which will give us 1 over 6, 1 over u squared, plus an integration constant c. Putting back the expression for u in terms of x, you get 1 over 6, u is 1 minus 3x, don't forget the square, plus c. And that is the result of the integration. Let's do the following integral. A and b are constants. So let's identify function fx as ax plus b. Why? So that f prime x is just a. The numerator contains a constant 1, but we can easily turn the numerator into a by multiplying the integral by 1 over a and write that a in the numerator. And we're going to get something like that. And now we are set. Note, if you take u to be that fx or ax plus b, then du is a dx, which is what appears on top. So let's rewrite this integral in terms of u. So you get du on the top. Now this term here is just ax plus b to the power 1 over 3. So it becomes u to the power 1 over 3. So what is the integral reduces into? It's u to the power minus 1 over 3 du, which is just 1 over a u 2/3 over 2/3 plus an integration constant c. Substituting u in terms of x and simplifying a little, you get 3. U is from here, ax plus b to the power 2/3 over 2 times a. And that is the result of integration. Let's look at this integral. Let's try the following substitution. Let's assume fx is 1 plus square root x. So f prime x is 1 over 2 square root x. So if you take u to be 1 plus square root x, then du is 1 over 2 square root x dx. So let's put everything in this integral, and you get j equals 1 plus square root x is your u, so u to the power n, dx over square root x from here is just 2 du. And this is a very easy integral to solve. It's 2un plus 1 over n plus 1 plus an integration constant. Substituting for the form of u in terms of x, you get 2, 1 plus square root x to the power n plus 1. Don't forget n plus 1 in the denominator, plus an integration constant. And that is your answer. Let's do the following. Let's call this integral j. Now the substitution is, of course, we can try the following. fx is 1 over a minus 1 over x. Now a is a constant, so in this integral, that a is a constant. And you can take your f prime x easily, which is just 1 over x squared. So if you take u to be 1 over a minus 1 over x, then du is just 1 over x squared dx. So let's put everything inside j, and j becomes the integral of u to the power n. Note from here, dx over x squared is just du, so it's du. And you get un plus 1 over n plus 1 plus integration constant. Substituting back the u from this expression, you get u is 1 over a minus 1 over x to the power n plus 1 over n plus 1 plus the integration constant. And that's the answer. And finally, this integral. So again, let's assume that fx, the best substitution would be 1 minus x squared. So f prime x is just minus 2x. So if you take u to be 1 minus x squared, so the differential of u is just minus 2x dx. So let's first rewrite this form so that to accommodate the substitutions. Now note that you have minus 2 there, so you have to multiply minus half in front, followed by minus 2 inside. Then you have x1 minus x squared dx. Now when you substitute or rewrite I in terms of u, now it simply becomes minus half minus 2x dx. From here is just du, and the remaining is just u to the power half. And this is just minus half u 3 over 2 over 3 over 2 plus an integration constant c, which is minus 1 over 3 u to the power 3 over 2 plus an integration constant c. Putting in the form of u in terms of x, it becomes 1 minus x squared to the power 3 over 2 plus an integration constant. And that's the final answer. Please like, share, and subscribe if you find this video useful. Thank you for watching.